All right, everybody, welcome back for Unit 1, Lesson 3 notes. This will be the conclusion of Unit 1, What is Science, where we're looking at, in this particular lesson, how to answer scientific questions. This particular lesson is going to be broken up into two different parts. Basically, how you can think of this, if you've ever done science fair, you were doing all these steps. There are 6 steps total that we'll be looking at, and we're going to start with step number 1. So step number 1 is coming up with a good science question. A good science question needs to hit 3 criteria. Number 1, it needs to be testable. Number 2, it needs to be based on some sort of an observation. And number 3, it needs to be free of personal opinion. If you look at the 3 examples I have there, each one of those is absolutely testable. Each one is also based on an observation. Where 2 of them are lacking would be they are not free of any sort of personal opinion or relating to you personally. And that would be what is wrong with my computer and where are my shoes. While testable and based on observations, in terms of looking at science and how to propose explanations of the natural world, those 2 really don't fit that criteria. But the first one, why are great white sharks around Seal Island? This one absolutely does. So this one can then be moving on to the next steps. In class, at this point, what we're going to do are a couple examples together, and then you'll receive a booklet. And on the front page of that booklet, you and a partner are going to be given some time, roughly 8 minutes, to go through the questions and circle the ones that you believe are good, testable questions. At the end of that time, we'll come back together and we will discuss what you guys came up with, because we need to make sure everybody has the right number of questions chosen so that we can move into the next step. All right, so the next step is developing a hypothesis. So using our booklet, we're going to continue to look at the steps of the scientific inquiry. So when you're coming up with a hypothesis, basically all this is an answer to that scientific question. It has to be testable, and it has to be in what we call an if-then format. The nice thing about a hypothesis is it doesn't matter if it's right or wrong. That's the whole point of the experiment, is to go through and do all the steps, and then at the end come up with a conclusion to find out if you were right or wrong based on all the data that you collected. The other cool thing is that when you're designing or coming up with a hypothesis, there can be more than one right way to answer it. So I use the first example from our booklet. Do Washington or Fuji apples have more seeds? I don't know the answer to this question, so I just took a guess here in the example and said, if I used Fuji apples, then they will have more seeds. Not sure if it's right or wrong. I'll do the experiment to find out that answer. But there are actually 3 more ways that you could write this particular hypothesis. I could say, if I use Fuji apples, then they will have less seeds. Or I can change the type of apple from the other one that's in the sentence. If I use Washington apples, then they will have more seeds. Or if I use Washington apples, they will have less seeds. So what you're going to do now with a partner is you're going to be given a little bit more time, and you guys are going to come up with a hypothesis for some of the remaining questions. We will do a couple examples in class, and then whatever's left, they'll either be 5 or 6, you will do those with your partner. Once you're done doing that, you will come see me. I will check them, and then you will move on to the next page in the booklet where you do some practice on your own. And this is where we cut off for the first round of Unit 3. We will be back with the second part in a later video. Thanks for watching.